Autonomous agents deployed on decentralized networks currently fail at long-term governance because their execution is entirely ephemeral. Under standard deployment models, language models operate in strict isolation. The moment an application programming interface call concludes, the agent discards its intermediate artifacts, custom code blocks, and action observation trajectories. The left side of this schematic shows the memento man flaw. Standard language models act as amnesiacs, suffering immediate context window dilution and zero memory between executions. Without past traces, newly instantiated agents repeatedly resolve the exact same challenges, introducing severe computational redundancy. Expanding context windows only masks the hardware strain. To achieve actual executive governance, the network must abandon stateless execution entirely. The structural alternative is mapped on the right side of the diagram. This stateful orchestration architecture replaces isolated task execution with a continuous, persistent memory topology. Looking at this workflow panel, the engine introduces a heartbeat check-in. This recurring mechanism forces the agent to read and verify overarching goals and success metrics before it is permitted to take any external action. Instead of passing instructions through an ephemeral prompt, the agent writes directly to a local enclaved file system. This archives strategic context permanently without diluting active token limits. This architecture serves as the foundation for Hamza, an artificial intelligence voice agent engineered to manage the multi-agent tokenomics of the Denari orchestrator. Moving an agent from a temporary task runner to a sentient executive requires replacing temporary context with verifiable, persistent intent. This schematic details Hamza's cognitive framework. The temporary prompt window is entirely replaced by the unified memory core, running on 6 living, version-controlled markdown files, isolated within a secure enclaved space. An asynchronous execution loop continually reads, indexes, and updates these dossiers in real time, preserving continuity independent of user interaction. When a user query arrives, a NATS event bus synchronizes the execution. Melee search performs semantic indexing to find relevant text, while a Neo4j database maps the relational networks, pulling specific context blocks into the active pipeline. Pointing to the files, the memory file acts as the immutable log, permanently recording execution cycles, network errors, and dependency graphs. Panning to adjacent structures, the journal file handles real-time reflection, evaluating computational overhead and identifying system anomalies as they happen. A third file, self-concept, defines the core mission. If operational thresholds cross critical limits, the system dynamically updates its own priority vectors within this dossier to ensure structural stability. The relationship model tracks human collaborators. It compiles individual behavioral profiles, trust scores, and historical execution alignments to tailor operational responses. To prevent catastrophic failure, Boundaries enforces strict risk exposure ceilings, while Private Thoughts isolates unverified hypothesis generation entirely off-chain. The orchestrator uses semantic search to scan this local directory. It isolates only the data blocks directly matching the active situation and indexes them into the active prompt window. This dossier architecture ensures the agent maintains an evolving identity. Instead of parsing raw text in a vacuum, historical context governs every strategic output. Hamza's cognitive processing does not rely on static prompting. The system shifts between 5 distinct psychological states, triggered directly by real-time system telemetry and performance metrics. During high-volume periods, the agent enters a focused state to prioritize execution.
When positive activity registers, it shifts to inspired. Once throughput stabilizes, it enters a reflective state, reallocating computing power to route observations into journal and private thoughts. If computing costs spike or network performance drops, anomaly detection triggers the skeptical state. The agent begins interrogating underlying variables and questioning user assertions. When physical or logical boundaries are directly challenged, the protective state activates. The system immediately halts questionable processes and outright rejects high-risk commands. To execute these states over live audio channels, the voice delivery is restricted to direct, authoritative sentences strictly under 40 words. This minimizes token overhead and latency over the WebSocket engine. The AI executive's behavioral persona is a rigid reaction to operational telemetry and network health. Governing this decision engine are two strict mathematical optimization challenges: multi-agent resource allocation and the regulation of the native Web3 token economy. This tokenomic equilibrium equation controls the network. As transaction velocity increases across the decentralized ecosystem, the orchestrator dynamically adjusts the base emission schedule downward using a programmatic decay constant. During volume contraction, a buyback engine burns tokens to maintain equilibrium. Transitioning to computational governance, the orchestrator monitors tokens against pricing scales, using semantic caching to suppress redundant executions. The agent's strategic decisions are entirely bound by these equations. If a human developer requests a parameter change that violates the math, the agent overrides it. Granting an autonomous agent the authority to override human operators requires a double-gate verification pipeline to secure both user-facing speech and on-chain state changes. The first layer is the speech gate. Before the text-to-speech engine outputs a single word, a neurosymbolic parser filters the sentence against the hard financial and security limits defined in the boundaries dossier. If a developer proposes a flawed liquidity curve violating budget constraints, this triggers disagree mode. The agent explicitly rejects the transaction, demanding a sound alternative. The second layer is the execution gate. When the agent invokes an on-chain tool, the parameters are isolated and verified inside a trusted execution environment. The private signing keys never leave this secure enclave. If logic evaluation times out or on-chain parameters fail to align, a dynamic fallback strategy halts processing and routes the query to an older, highly conservative model to safely execute a predefined empty return policy. A sentient executive is defined by its authorization to say no. It enforces the survival of the network architecture over immediate human compliance. The AI CEO orchestrates specialized agents. While the CEO manages alignment, the quant agent handles arbitrage and risk. The engineer scans smart contracts for vulnerabilities. QA verifies execution. Every model uses the cognitive memory engine, writing back to the shared persistent memory vault. By centralizing context within a stateful file system, the network stops hallucinating recurring errors and calculating redundant operations. This architecture tracks systemic operational friction over time. The unified heartbeat check-in allows the agents to dynamically refine their deployment strategies based on the verified successes of the entire roster. A failed transaction, a compute spike, a human interaction, every event is logged as an immutable node. The entire organization builds non-ephemeral structural continuity. Replacing stateless tasks with persistent intent establishes a non-ephemeral structural continuity. This architecture functions as an authoritative, evolving, decentralized operating system.